Hi, welcome to video 1.5a. 1.5 is the last section in chapter 1. So we will be done with limits and continuity, and we'll be moving on to differentiation soon. Okay, so section 1.5 is called infinite limits, and this means that the answer to your limit is either infinity or negative infinity. So when is this going to happen? And this is when it's going to happen, when substitution yields a non-zero over 0. So here's an example. Limit as x approaches 3, let's say from the right, of x plus 1 over x minus 3. Okay, so it's not a piece function, so your first attempt would be just plug in 3. Well, 3 plus 1 is 4, 3 minus 3 is 0. Now remember, if it was 0 over 4, the answer is 0. If it was 0 over 0, you could try factoring, you could try rationalizing, you could try simplifying. But when it's a non-zero over 0, you know that this is going to give either infinity or negative infinity. Now, of course, you know this because when you graphed these, y equals x plus 1 over x minus 3, you knew that there was a vertical asymptote at x equals 3. And of course, on either side of the vertical asymptote, the graph approaches either infinity or negative infinity. Sorry about the loud motorcycle. I don't know who that is. And I'm at school. Anyways, so if you think about it, and the way I can convince you that this is either infinity or negative infinity, if you think, do not substitute, but if you think of a number close to 3 from the right, like 3.01, well, that would give 4 over 0.01, which is 4 over 1/100th, which is actually 400. Now, if I approach from the left, let's say, if you thought about it as 2.9 plus 1 over 2.9 minus 3, well, this is negative 1/10, so you would multiply that by negative 10, and that would give negative 39. So, and of course, the closer and closer the number is down here, the bigger that denominator will be, which means when you multiply by the reciprocal, the larger your answer will be. So, it is a common occurrence. This will come up quite a bit. When you substitute and get non-zero over 0, you will either have infinity or negative infinity. Now, here is the key thing. This red box right here is my way, not the book's way, but my way, and what I will be asking to see on a test. First, I'm going to ask you over the equal sign to show me what you got when you substituted, because this is going to be your cue that you're dealing with non-zero over 0, meaning you're going to have to do this big red box. So the numerator, as you can see, is positive. Now, I'm approaching 2 from the left. So 2 minus 2 is 0, but if I approach 2 from the left, which is like 1.9, 1.9 minus 2 would be negative. So I am approaching 0, but I'm approaching it from the left side of 0, which means I'm approaching it through negative values. Now, we already knew the non-zero over 0 is going to give infinity or negative infinity. What this does is tells us that positive over negative is negative infinity. Now, I know it also doesn't exist, but that's not as descriptive of an answer as that. So just to go over it, if you end up with positive over 0 through positive, that's positive infinity. Positive over 0 through negative is negative infinity. Negative over 0 through positive is negative infinity. And negative over 0 through negative is positive infinity. So it's like you always did. Divide a positive by a positive, you get a positive. Divide a positive by a negative, you get a negative. Okay, so here's an example, another example. Limit as x approaches 2 from the right of x plus 2 over x plus 3 over x minus 2. If I just plugged in 2, I would get 5 over 0. That tells me my answer is either infinity or negative infinity. I think underneath of a number close to 2 but to the right, which is like 2 plus 1, 2.1. 2.1 minus 2 would give a positive. So that my denominator, you have to write 0 through positive. You can't say a positive over a positive gives infinity. It has to be a non-zero numerator, either a positive or negative number, and the denominator is approaching 0 through, and that's THRU, because it's a good abbreviation for that other long version of through. 0 through positives. The two positives make it a positive. The fact that it was non-zero over 0 tells you it's some kind of an infinity. Okay, so a couple more examples. If I approach 2 from the right, well, first I'll plug in 2. 1 minus 2 is negative 1. 2 minus 2 is 0. So there's my non-zero over 0. I know my answer is going to be either infinity or negative infinity. Approaching 2 from the right, think of 2.1. 2 minus 2.1 would actually be negative. So I'll end up with a negative constant on top, and I'm approaching 0 through negative values on the bottom. My answer will be positive. Take the same exact example, but approach 2 from the left. Think 1.9. 2 minus 1.9, of course, will be positive. So this time I'll have a negative constant on top, and I'll be approaching 0 through positives. That'll give me negative infinity. Here's another example. Limit as x approaches 2 from the left of x plus 5 over 2 minus x. Plug the 2 in, you'll get 7 over 0, which tells us the answer is either infinity or negative infinity. Think 1.9, 2 minus 1.9. This is the box that's going to earn you the points. Positive over 0 through positive. Now, this brings us to the formal definition of a vertical asymptote. So here's my version of it. X equals c, where c is a real number, is a vertical asymptote of f of x if the limit as x approaches c from the left of f of x is either infinity or negative infinity, and or the graph doesn't even have to exist on the other side of the vertical asymptote, but it might. But and or the limit as x approaches c from the right of f of x equals either infinity or negative infinity. So here's the 4 common examples of when the graph approaches the vertical asymptote from both sides. As you can see, from the left it's going up to infinity, from the right down to negative infinity, from the left down to negative infinity, from the right up to positive infinity. From the left goes up to positive infinity. Limit as x approaches this number from the right, also positive infinity. Limit as x approaches that number from the left, negative infinity. Limit as x approaches that same number from the right, negative infinity. But if you think of a graph like y equals ln x, it does have a vertical asymptote, but the graph only approaches it from one side. When they start talking about ln x and e to the x, honestly, I would graph it. If you know what the graph looks like, you can observe the graph and actually say to yourself, oh look, I'm approaching 0 from the left. That means here I am, right? 0 from the right is approaching negative infinity, as you can see right here, right? But 0 from the left, there is no graph. It simply doesn't exist. It's that simple. Also, the thing you need to understand is it's possible that to have 2 vertical asymptotes and the graph only approaches one of them from one side and approaches the other one from only one side as well. That can happen. Now again, if you're looking at this picture, the limit as x approaches 3 from the left doesn't exist because there's no points in this area here, 3 from the left. But if you approach 3 from the right side of 3, you can see that it's going up to positive infinity. Okay? Same thing over here. If you approach negative 3 from the right side, there's nothing. If you approach negative 3 from the left side, it's going down to negative infinity. Again, here, limit as x approaches 0 from the right is negative infinity. Limit as x approaches 0 from the left doesn't exist. We already talked about that one. And that's the end of video 1.5a, a nice short one for you.